I don't know. Well, I want to start, but I don't know how. I'm not really like. No, see, that's a bit weird.
Hello, everybody, for coming.
Yeah.
This is just.
Yeah. Wow.
And Sarada would probably like me to say that we are hiring. So if anyone wants a job, I'm in.
Okay. Oh, you need to do something? Oh, okay, sorry. First of all, thanks everybody for coming. Sorry, we started a little bit late because I was stuck in an Uber and then that wasn't working and stuff like that. So, a little bit of context because I don't know if everybody has context. I gave a presentation a bit like that at one of our clients at ThoughtWorks a few weeks ago, and it took me quite a few hours to put the slides together, I thought I would share them with people in general. Because when you put like 30 hours in a presentation, it's good to be able to reuse it so that I don't feel like I actually wasted my time. The thing is, I removed the slides related to the client because it doesn't concern you at all, but I had enough time to add a lot more slides, which means that I'm going to try to keep it under an hour, but there was so much I wanted to say that I'm going to try and maybe talk fast. But please stop me if something doesn't make sense. This is kind of like an intro if you've never looked into machine learning. If you have looked into some of the buzzwords, you might already know some of the stuff that are going to be in these slides. And if you know a little bit more and you realize that I said something wrong, please don't hesitate to just put your hand up and be like, well, actually, it's not that, it's that. I'm not an expert. Hello? Is someone actually joining the meeting? Am I expecting? Oh, right. I was like, who is joining the meeting? All right. What is that actually for?
We're just recording.
Oh, well, okay. Oh, fine. So, okay, let's start. So what I'm going to try and cover, it's like going to be a lot of things. So an hour is very short, so you're not going to be leaving this room being an expert, but at least if you're a bit more comfortable with certain types of algorithms, certain ways machine learning can be applied to different fields, there's just a tiny bit of code. I said that there would be no code involved, but if everybody here is a dev, right? Yeah? Okay, cool. So I'm just going to show one sample. I'm going to go through it very quickly just to show that it doesn't have to be really hard to get started. And just show some examples with a live demo and then talk about the limits of machine learning and AI, which is actually something that's very interesting. And then some resources. All right, so what is machine learning? So it's very trendy now, but just to make sure that everybody's on the same level, I started with a definition that you can probably find on Wikipedia. But it's the computational learning based on algorithms. So you're teaching a computer to recognize patterns by example, but you're not actually explicitly programming it to give you a certain answer. You let it kind of like learn patterns based on data and give you an answer. So if you compare it to traditional programming, sorry, I hope you can see. So let's say you want to classify emails to see spam emails. So in traditional programming, you'd have like, oh, if email contains Viagra, but oh, the I is actually an exclamation mark, then it's like, put it in my spam box. Or if it contains, winner or congratulations, then put it in my spam box. But the thing is, with machine learning, you would actually have a bunch of data that you have already with spam emails and non-spam emails, and you would build a predictive model that can classify itself, the spam emails, so that even if there's emails with a new word coming up that is not in your if statement, it would actually still, the probability of it being a spam email would just allow you to put it in your spam box without having to write the condition yourself. Just like very, very small example. If you start looking into the topic as well, a lot of people get confused between AI, machine learning, and deep learning. And sometimes people use AI everywhere where what they actually mean is machine learning. So AI is kind of like the global term that's trying to kind of talk about the human intelligence exhibited by machines. But then to kind of achieve AI, you need machine learning, which are the actual systems that can learn from the experience to find patterns in a set of data. And then deep learning is one technique of machine learning. And it's a technique, yeah, for implementing machine learning, as I wrote. Example, deep neural networks. So you have deep learning, that's a technique that's driving machine learning as a whole system that can then enable to have artificial intelligence. So it's like buzzwords, but people kind of like use them in the wrong places. But hopefully maybe that makes a bit more sense, kind of like subsets of each other. So how does it work in a very simple graph? So you have training data, and I'll show a few examples later. So you have like a bunch of data that you're going to feed into an algorithm to learn patterns in that data. And what it's going to create is a classifier. And this classifier is going to be able to classify new data based on what it's learned from learning the patterns. And then it gives you a prediction. So the new data is data that it has never seen before. But based on what it's learning from the algorithm, it will be able to classify that new data anyway and give you a prediction. It will probably make a bit more sense when I talk about examples later, but it's kind of like the three main steps of how it works. So, algorithms. You have more types of algorithms, but the ones that you hear about the most is supervised learning, unsupervised learning, and reinforcement learning. And the difference is, in supervised learning, you develop a predictive model and you have input and output data. And we'll talk about what this data is later. But in unsupervised learning, you group data only based on the input. So you don't have the output data, you just use the input data to kind of group and identify patterns. And in reinforcement learning, you learn by trial and error through reward and punishment. So that's, you can see sometimes example of little games where if a machine does well, then it's like rewarded and it tries again and it learns like a behavior based on being rewarded or punished. But we won't talk about this one because I don't really know that one well. I have worked more with supervised learning. So let's start with an example. Let's say you want to know if a drink is a beer or a wine. So when you look at it, you know because your brain like knows, but a machine doesn't. The only thing that you know about this drink is the color and the alcohol percentage. So these are called features of your drink. So you have to think about it as like a table of data. So what's going to happen is that you start with your input and your output. So the input is the stuff that you know, the features. So you know that a beer is yellow and the alcohol percentage is like around 4 or something like that. And you have a table of data, but that's just the input. The output on the other side is what we call the label. So you have features and label, input and output. So you have this data that you feed into the learning algorithm, and it's going to look at all these data and try to make sense of it. It doesn't actually know, right? So it's going to be like, so it's going to create a predictive model, and then when you give it a new drink that it has not seen before, so don't think about the image, only think about the data. So let's say I have color, oh, it's light yellow, and alcohol is 11%. Is it beer or is it wine? Well, if the predictive model is good enough, it should tell you, oh, it's wine. But then you have maybe a more practical example. Oh, actually, that's not there. I'm going to go to it later. So if you think about it, that's a really short code sample using scikit-learn, which is something that I've used before, which is one of the tools that I'll talk about later. You only start by importing a Python package called NumPy, which I think is to do calculations. I didn't actually look into it. But you have your features. So I should have replaced that with wine and beer. But let's say you have an array of number, and as you can see, the 3 first ones are all negative, and the 3 last ones are positive. And then in your label, you say, okay, the label of this feature is 1, this feature is 1. So you can see that the negative numbers are going to be labeled 1, and the positive numbers are going to be labeled 2. Then you, from scikit-learn, the type of algorithm that I've picked there was naive Bayes, which is one type of algorithm, but there's another one. I mean, there's a lot of ones actually. And we create an we instantiate this, like a CLF is for classifier. I should have written that better. But we kind of like start an instance of that algorithm or that classifier. We give it the features and the labels so it can learn from it. And then our prediction, so that's going to be our kind of like predictive model. And we give it that, like a negative number. And when we print the prediction, it gives us 1, because based on the features and label that we gave it before, we saw that the negative numbers were classified as 1 and not 2. So that's a bit of a boring problem, because it doesn't actually, you know, take wine or beer or cats or dogs or whatever. But it's just to show you that it's looking at the data, trying to make sense of it, and trying to classify a new input that it has not seen before into one of these categories. So if we think about an example that's a bit more practical, you have a house and you want to figure out, let's say you want to sell it, and you want to figure out the price. The only thing that you know about your house are its features. So you know the distance from the city, the type of the house, the number of rooms, bedrooms, windows, color of the walls, paintings, whatever. So you know all these things about the house and you want to figure out its price on the market. So same thing. You have all the features, and our label in this case is going to be the price. So that's going to be the houses on the market. So this is not your house. This is the house. Let's say you can download a data set of all the houses in your neighborhood, and you have this table there with the price, and you're going to feed it to an algorithm, predictive model, the same way as before. And let's say this is my house, or a house that is not in the data set, and I give it the same features, and it should actually come back to you with a prediction of the price. Does that kind of make sense so far? I'm trying, yeah. But then you have unsupervised learning. And this is where you see that depending on the type of algorithm that you pick, it might not be the right one for the problem that you're trying to solve. Because unsupervised learning, you don't have the output data. You have all the features of your house, but you don't have the price. Because what you're trying to identify, you're not actually trying to map. Like, it won't answer the question, what's the price of the house? It will actually instead put all the houses in your data set into clusters. So it will say, oh, maybe all the houses that are the same features are together, and things like that. So to answer the price of a house, it's not the right algorithm. But if you wanted to identify patterns in customer behavior, for example, you go to Woolies or Coles, and they probably have a massive data set of who buys what, when, how many times, and things like that. And you could actually, if you're in marketing or advertising, you could target different campaigns depending on different people just by analyzing what they buy and when. So there was this case of, I think it was Target, who sent an advertising for babies and pregnancy and stuff to like a household. The thing is, the daughter didn't tell the parents that she was pregnant. So, and it was like a big issue because it was like, well, when should you actually, like sometimes data is a bit sensitive, when should you actually use that data to, like for advertising? And sometimes I think Facebook was saying that they notified a certain behavior in how many times people were sharing on Facebook before getting into a relationship. So sometimes Facebook would actually know who you're going to be in a relationship with and when before you actually even know. That's a bit weird. But that's when, like, that's kind of when unsupervised learning works better. It's like you're not actually trying to answer a specific question, like what is the price of my house, or is this a cat or a dog? But it's more when you're trying to group people or things into clusters and then dig into these groups and identify different patterns. All right, so the steps of going through machine learning. So you have to gather your data. Sometimes that's a very hard thing as well, because if you find an open source data set, you're fine. But depending on the problem that you want to solve, you have to gather the data yourself. And you have to prepare the data. And preparing the data means that sometimes you have to manually, if you do supervised learning and you have a data set of features and labels, you have to put the labels yourself. So I don't have another example right now, but sometimes you have to manually say, oh, you know, this is a car, this is a car, this is a motorcycle, this is like, you know, and that's like preparing a data set. Then you have to choose the model depending on the question that you have. You have to train the algorithm, sometimes, actually most of the time, multiple times. And you have to do an evaluation. So when you have your data set, usually a part of it is used for training and a part of it is used for testing the quality of your predictive model. So you take your entire data set and 80% is for training, and you keep the 20%, like you split it just like, you know, 80-20. And you take that 20% to just evaluate that your predictive model is right. So that 20%, you also have the feature and labels, but you just test that the algorithm actually is figuring things out properly. Then you have hyperparameter tuning. So different algorithms have different parameters that you can tune to see how accurate your predictive model is. And then you get the prediction. So you probably have to play a little bit with that to really understand these steps. Like the first steps kind of make sense. And then evaluation and tuning and prediction, it's kind of like you just play with the data and with your algorithm, and you see if, because you can get a prediction score, and it's between 0 and 1, and sometimes when you tune a parameter, you can get a better result, so you know that you should go that way. Okay, that's a lot of text. But things to know is that choosing your input features can have a big impact on the quality of the system. If we go back to the example of figuring out the price of the house. We know the color of the carpet, but does it really matter? I don't actually think that the color of my carpet determines the price of my house. So sometimes you have to select the features that you think are actually right and will actually have an impact on your prediction. And sometimes you have to try different features to see which ones impact the actual result. It takes practice to figure out the best features. People, if you start watching a lot of talks, they'll say it's more of an art than a science. When you have a big data set, you don't actually know exactly which features are going to be the best ones. So sometimes, actually most of the time, when you train an algorithm, you actually create a graph out of it. Because when you see a chunk of data, if you visualize it in a graph, and I should have put pictures, you can see the clusters of data rather than just getting back a massive table of like, if you wanted to visualize the behavior of customers that buy from Kohl's, you would probably want to put them in a graph to see, oh, you know, these people do this or these people do this. And humans can easily understand 2D or 3D graphs, but computers and machine learning can understand millions of dimensions. So you end up with graphs that have like millions of different layers that you wouldn't understand as a human, but computers can. As I said, you should split the data between training and evaluation. And the quality of the training data. All right. Yes, the quality of the training data is important. Yeah, put shit in, get shit out. I should have removed that. But it's not only the features that you should pick, it's also the training data. Sometimes you have open source data sets, but they're actually rubbish. We tried to do sentiment analysis on pieces of text. So you get text written by humans and you try to understand if the emotion is happy or sad or things like that. And we tried to use as a training data 40,000 tweets that were, so you had the tweet and then you had the label was, you know, emotions. The thing is, like, it was rubbish. Like, it was not accurate at all because the training data was shit. So it's not only the features, it's also make sure that your data is not shit. Okay, oh my god, all right. So that is even more in like, yeah, okay, that's a deeper level. But that is something that a lot of people talk about, you know, neural networks everywhere. So I'm going to try and explain that. I haven't actually played with them enough, but I tried to do a graph that will hopefully make sense. So as a definition, it tries to, so it's arranged in layers, and it tries to mimic the human brain. And so it creates a network of artificial neurons. And these artificial neurons are called perceptrons, and I love that name. Like, perceptrons. It's kind of like a robot, I don't know. So yes, that's just a definition. But I guess we had to talk like a bit about the anatomy of a real neuron to understand how the artificial ones work. So the base, I mean, the thing that you actually care about is like the nucleus. So that's going to be like, let's say, the main part where the data comes. And then it kind of goes into the axon to the other neuron, if I understand well, but it's probably not that. And direction of like the message travels in one direction. There are some algorithms where sometimes the message can go back in the other direction, but I'm not going to go into that because I don't even remember myself. I guess maybe you've seen things like that. I drew these squares and lines myself. It took me a long time. So you can see I got lazy. I didn't want to finish. But like you just put that here and it's the same thing. So I took an example of computer vision and trying to figure out handwritten digits because to me it kind of made more sense. So when you see this, you know it's a 3, right? But a computer doesn't know it's a 3. Like it's like a 28 by 28 pixel like grid. And you can use deep neural networks to, all right, let me take back. Okay, so you have 28 by 28. So the way you can feed that as data to an algorithm is to give it every pixel. So you multiply 28 by 28, which is 784 inputs. And your neurons here are all the inputs. So your input layer is going to be 784 kind of neurons, and the value of it is going to be the grayscale of the image. So it's either like black or gray. So it's a value between 0 and 1, 0 being black, 1 being white. And you give it this input layer of just numbers. So it's going to be probably a massive array of 784 numbers between 0 and 1. So then you have what we call the hidden layers. And you can, it doesn't have to be 2, it can be more than 2, it can be probably even just 1. I don't exactly know how you figure out the amount of layers that you want, maybe probably depending on the complexity of your problem. But let's say, and I don't know neither, why you would pick 7 or 5. I don't know if there's an actual science or if it's more art, or let's figure out if it works better. The thing with neural networks is that each of your neurons in the input layer is going to be connected to the other layer. So you end up with 5,488 connections because you do 784 times 7. So that's your kind of like first connection where it's trying to figure out what this is. And then you have a second layer where you do 7 by 5. So you have 35 connections between the neurons. And your output layer can only be between 0 and 9 because numbers are only between 0 and 9. So your output can only be, oh, is this a 0? Is this a 1? Is this a 2? Blah, blah, blah. So you have 10 possible classifications. So you give it your data, it goes through different layers of neurons, and in the end, it gives you the classification that's the most strongly activated output neuron. So in between, and what I'm not going to talk about because I don't really understand it, is that these connections have weights, and I don't know how you define that. So if someone can tell me later, I would really appreciate it. I need to watch more videos. But I don't know exactly how you define the weights of this connection. Maybe it's depending on, if it's 1, then the weight will be higher because I'm trying to figure out the shape. Maybe that's that, I don't know. And you also introduce a bias, and I don't know what this is neither. These are just words. And depending on how strong the connections are between neurons, your output is going to have, probably the number 3 will have, it will be a stronger neuron. So the value between 0 and 1, maybe 3 will be a 0.8. So, it must be a 3. So I hope at that point you kind of appreciate how your brain works because you don't have to go through that. It's like, ooh, it's a 3, well, whatever. And it works with everything. And the more you think about it, the more you actually realize how awesome it is. It's like you can look at a bottle and I know it's a bottle. And I could see another bottle, that's a bottle as well. And I don't have to, it's just like, my God, I just know everything. I don't have to go through that stuff. That's why when people think about super intelligence, like killer robots, I'm just like, yeah, right, like see what you have to do to see that that's a 3. I mean, I don't think there's killer robots anytime soon. I mean, apart from like drones, but that's still powered by humans, so it doesn't matter. But so that's kind of like a very basic example of a deep neural network. And same, you have different different ways of building stuff, and there's so many buzzwords that are actually quite hard to understand. But that's more advanced. You don't have to start with a deep neural network. Where am I going next? Tools. That's also quite exciting because so there's more tools than that. But what I really liked to see is that, so TensorFlow is made by Google, and you can do it in Python or now JavaScript. But then you have scikit-learn, which is a really cool website where it's like in Python, but you have a lot of different examples, and they go through all the different types of algorithm, and you can try and stuff like that. Then you have Core ML by Apple, which is in Swift. So depending on if you want to try Swift, you could even do that. Then Torch, I haven't tried it, so I'm not even sure which language it's in. But then you have something called PyTorch, which I think is different in Python. And then you have Microsoft also looking into that stuff. And you have Keras, and that's the Google services, and Amazon. So all the kind of very big companies are getting into that stuff. So obviously it must be a bit interesting. But it's just like there's a lot of different tools and a lot of different languages. So no matter what you want to try, start with, even if you're really more comfortable in JavaScript, you can start with TensorFlow JS, which I haven't used, but I'm sure that they wrote good jokes about it. Applications, okay. That I can probably go quickly around it. So just to talk about different fields where it can be used. In insurance, you can approve claims without having to do it manually, depending on what other claims looked like before. Then you can have fraud detection. I don't exactly know how insurance works, so I don't claim anything. But I'm sure there are some stuff that looks like a fraudulent claim versus a non-fraudulent claim. In health, that's even better because you can detect skin cancer. So by taking pictures of different types of skin cancer, you can now you have machine learning systems assisting doctors in predicting if someone has skin cancer or not. You also have neurotech, where people try to understand how the brain works and apply machine learning to, for example, brain waves or things like that. Self-driving cars, of course. Home automation, some of you may have a Google Home or an Alexa. Recommendation engines, we don't even think about it anymore, but like the way Spotify or YouTube give you stuff, that's also machine learning. It's been there for ages. Like basically everywhere. And art, because that's like one of my favorites. I need to put in there. So examples. I forgot I wanted to do this one. Yes, so when I was talking about the prediction of handwritten digits, I actually wanted to show you one of the examples. And how do I exit? Do I have the code? I forgot I wanted to show that. All right, so I need to check. So I have, I think, a pre-trained model. And I don't remember how to run the code. Should be in the README. Oh, it should be just this one. Okay, so you can see here that I have the number 5 as a PNG, but I know it's a number 5. That doesn't know it's a number 5. So I think I need to remember. I think it's Python predict 1. Oh no, not 2. And then I think I just give it the number of the PNG. Is that gonna work? It's been a while. Cool. All right. So forget about this because that's just messages. But look, it knew it was 5. Or maybe you don't see. All right. I'll try again. Maybe you'll see that. All right. See? 5. Woo. And then I have another number 0. Okay. So I'll do that with number 0 as well. Hey, 0. And it just like training. So it's used the data set that's a famous one called that. I don't like MNIST, I guess, for character recognition, and that's one of the basic examples that you have on the TensorFlow website. Actually, I think. So I did not write this code. I totally stole it. But I just wanted to show that it's pretty powerful. And I think you do also have a data set about letters, but I'm not sure. we started to get to. Okay, so home automation. So this little device here actually uses Raspberry Pi and a camera, and it's open source, and you can build it yourself. And the way it works is that you basically just train it again and again to recognize a gesture. So, oh, I open a book, and then you connect it to your light, so that, you know, when you open your book, it just turns on your light. And you can place it everywhere. It has a camera, so as long as, I think you connect to an app on your phone, and you just say, you know, record, and then you do something, and then you stop, and you do it again and again and again, and it will recognize gestures, and you can use that data to do whatever you want. Oh yeah, manufacturing. Some of you may have seen that, how they use kind of like self-driving, yeah, that's a GIF, self-driving robots to circulate autonomously in a factory to just classify parcels. So there's no human error anymore, because you scan the barcode of what you want to classify, and then they know exactly where they have to go. So of course that will put a lot of people without jobs, which is bad. But look, I mean, like, it's crazy. All right, maybe. So maybe now people can do more interesting stuff than classifying. I don't know. I'm not going to go into that topic. But it's quite interesting that like it is getting into that kind of stuff, and maybe we're not there yet, but they're already starting to implement that in, I think it was a Chinese factory. Okay, so that is, to me, really impressive. So this machine learning algorithm was fed with a lot of paintings, and it's trying to make sense of what's happening on the left. So all it knows is the data set of paintings that it's seen before, and it doesn't know what that is. So it's kind of like going through, and it's like, oh, I've seen something that looks like that, and it looked like that. Oh, and I've seen a nose, and it kind of looks like that. And it's really interesting to see that. So the machine doesn't know, it's just trying to make sense of what it's seeing now based on what it's seen before. It can't just come up with a massive, like, something that it hasn't seen. So it's just trying to make sense of new things and pull back what it's seen before and trying to adapt it. So I don't remember the name of the dude who does that, but he also did it with his own face, where he was in front of his webcam, and you could see like a kind of old school painting and stuff. So that's really impressive to me, because it's live using the webcam, and it's that will definitely use deep neural networks. I think they even called convolutional neural networks, but I don't know how they work. Yeah, another example that I think is even more beautiful. I would totally buy that painting. So it's same thing. It's like it was fed with a few different paintings, and it's trying to understand what is on the left. It's never seen that before. It doesn't know it's a charger. It doesn't know it's like some kind of like tissue or whatever. And it's been fed with paintings of, I guess, the ocean. I don't know if that's a famous one. But yeah, and it's just trying to understand what it is and just put colors, and I think it's really pretty. Yeah. All right, so that is something that I built, and what's funny is that I realized today that I was wrong the entire time. So yeah, all right. So what I wanted to do is, using this sensor there, I'm recording customized gestures. So I wanted to do a swipe right, swipe left, and this sensor has never seen that before neither. It's kind of like microwave motion sensor. So it's, if I understand well, it's tracking the changes in frequency and what's happening in the environment around it. So when I move, it should be, you know, doing something that it can recognize between this one and this one. So I'm kind of like predicting, and I'm going to try and do it live, but you'll see that the accuracy at the moment is only 0.5. So I kind of have 50% chance that it's not going to predict the right thing. But that's the issue as well. I have to train it again and again and again. And I'll show you I'll tell you what's funny later. I'm quite ashamed. But all right, so I have it here. And so I have my, is it? No, that's the other one. So if I just show you, so I trained it about 2,740 times, I think. So all these files are me doing either swipe right or swipe left. So it's going to take all these files, trying to do a predictive model out of it, and oh no, I'm not in the wrong one. So, and then I should do Python start and predict. And I can already bet it's not going to work. But, so if I do the swipe up, oh, I did. So U is up, right? And D is down. I just got lazy. And if I do, oh, see, not working. So, hey, I did up and it did down. So that's the thing. It's like up, okay, down, okay, and okay. So 50%, like an accuracy of 0.5 is really shit. And the reason why is because I realized today that I was training it on the wrong side of the sensor. So I should have trained it on the other side. And because I know that sometimes it takes you like thousands of samples to get it right, but after 3,000 times where it still goes between 0.53 and 0.49, I'm just like, I was expecting at least a 0.6, you know, like, yeah, and then I realized I should have done it on the other side. That's great. So, and also what I realized is that I actually don't want to use it that way. I want to use it like that way. So I'm going to have to redo it anyway 1,000 times because like the gesture, it would recognize it only here, but if I actually want to use it that way to be able to do above it, it won't recognize the same gesture, so I have to retrain it. But that was an experiment. At first I was excited and then I was like, yeah, okay, I'm so stupid. But that's like the beginning of my experiment. The limits. Yes, because there are limits. So you do need a very large amount of data. Yeah, I don't think I can say it enough. Sometimes I think the data set for the handwritten digits is like a few 100,000 files or like, yeah, I don't know, like, yeah, files or samples of data. So you do need quite a lot. It can take a lot of time to train and refine models. At some point I was trying to do what we call style transfer. So it's taking kind of like two images and trying to draw the second images in the style of the first one. And that took, for my first iteration, it took 6 hours to train. And the result wasn't really great. So then I tried again and it was another 6 hours. So it could take quite a lot of time. I think especially when you deal with images, but even when I was trying to do sentiment analysis, at the end of the day it wasn't done and I had to close my laptop. So I was just like, I'm not going to wait 8 hours to see if the results are right, even if it's like, if the accuracy is only 0.5, that's a waste of time. You can need some powerful computers. When I run the style transfer algorithm, my computer starts to get a bit hot, and I think the more powerful the better because it can run faster. It's still, when I say it's still early stages, machine learning algorithms have been around for a while, but you can fool them quite easily. There was just an example I saw where computer vision systems can be fooled, especially where they were 3D printing a little turtle and it was recognizing that it was a turtle. But then when you just change a little bit the pattern on top of the turtle, it thinks it's a rifle. And I don't understand how it can think it's a rifle. But it's like, that's what I mean when I say still early stages. I think there's still a lot of work that can be done to not be able to fool systems. And also, I think a very interesting limit is around biases and ethics, and I'm going to kind of dig a bit into that. So even if you don't want it, humans are biased, and as we teach the machines will be biased. And then you have questions like, well, if something bad happens, who is actually responsible? Is it the dev? Can an algorithm be responsible? I don't know. And you also have sometimes computer vision algorithms used to predict criminals based on the government photos IDs. So they have a database of criminals and they have their photos, and then they try to predict based on government photo IDs if someone looks more like a criminal than others. And I think that's horrible. You shouldn't do that. I think it's like, well, what if I look like a criminal but the accuracy is only 0.6, then I still have 40% chance I'm not a criminal. So you don't want to play with that kind of stuff. And I think, yeah, there was at some point they were trying to recognize if someone was gay based on a photo, and it was actually, I mean, they were saying that it was quite accurate, but the thing is they didn't show the data that they were using to train this algorithm. So a lot of times, yeah, as I was saying, the quality of the data that you put in, you know, like what you get out is quite, I mean, when it deals with that kind of issues, you have to be really careful. And I was watching a video, and I put the link at the end. MIT did a course on the ethics of AI, and they put the videos online. I started watching it, and it's really, really interesting, because then it's not only machines. Then I mean, if you start thinking about AI and machine learning, then you have to also involve law about, you know, who's responsible, and then you also have philosophy. It's like, well, if you can replace the human brain with a machine, then what are we doing here? And it's kind of like, it's not only tech, it's like a lot of different issues or different topics that are put together to talk about that stuff. And yeah, they were saying, like, is it the machine's job to make society fair, or is it, you know, should we make ourselves, like, our society fair first, and then teach the machine with like non-biased stuff? Okay, oh, maybe I don't know if you can see that, but I can share the slides. I mean, there's a link at the bottom. But they were looking at how Google Translate is biased, because they were using neutral language, like I think it was Turkish, and they were using Google Translate, and you have, he is an engineer, she is a nurse, and you're like, she is a teacher, and you're like, he is hardworking, she is lazy. And you had, and it's like, it's not the machine, it's not the algorithm, it's the way we talk, it's the way, like, this machine has been trained with text that probably comes from searches on Google, or from articles, or from books. And if our society is biased, then the machine will be too. Like what do you actually expect, really? Oh my god, I need to show that video, because I think I have to exit of that as well. That is like another example of, let me try, oh, is it going to be pixelated? Maybe a little bit. But, all right, look at that. So, like a white person tries to get soap, and it's fine. And then, person of color, and wait until the end of the video, because it's even more silly. And I thought it was movement based, but sometimes, I mean, some soap dispensers must be with like a kind of color sensor or a camera. And then, wait, I don't have the sound, but boom, so, and I was just like, and this is also, I mean, you could even come back to the, yeah, and then you try again, and boom, and no, not working. It's like, you don't get no soap. So it's kind of like, it could come back also with the topic of diversity, where if you build a product for everybody, then make sure everybody builds it, or at least test it with everybody. There's a lot of times where even computer vision frameworks made in JavaScript that I've tried with, they've been only tested with white people, and they can't recognize a person of color. It's like, well, I mean, and that's only like, in computer vision is like a type of machine learning, but there's a lot of bias that you have to, and you don't think about it unless you actually see it or someone else talks about it. Okay, just a little recap. I mean, little, that's quite a lot of points, but there are different types of algorithms for different problems. You don't need a strong background in math to get started. A lot of algorithms, if you just understand what this algorithm is good at, you don't need to look behind the code, you can just use it. The issue is if a problem hasn't been solved before and you want to create your own algorithm, then you actually definitely need to look into hardcore math. Yeah, even if you do a course online, there's a moment where I even was like, whoa, okay, I don't get this. But I mean, I guess it's just like learning anything, right? You have tools available in different languages. Don't be scared to try something that's not in JavaScript. Again, scikit-learn in Python is really good, and Python looks like Ruby. Like, it's so readable. It's really nice. There are applications in a lot of industries, so maybe, you know, where you work, try to think, oh, if you have some kind of data, you know, can I do something with it? The power of machine learning is that you can create a system that can be reused without having to rewrite the code, because like if you create a classifier, maybe what needs to change is just your input and output data, but you don't have to rewrite the classifier entirely. So yeah, depending on the types of problems that you want to solve, you can just change the data, but the code itself is going to do the same thing. A machine learning system cannot predict something it does not know about. And I think that goes back with the whole super intelligent robot and stuff. It's like, we're very far. Like, we're just teaching it stuff that we know. How can you expect a machine to just know things it's never seen before? And again, results depend on the quality and quantity of the data set. And I'm almost done. Resources, I put a few, there are a lot of resources online. I started this Udacity Intro to Machine Learning online course. That was my first one. It's very nice until a certain point, and then they started going quite fast about the algorithm, and I kind of like, whoa, I need to stop for a bit. Google has a machine learning crash course. I haven't tried it, but I want to. So if you want to as well. There's a free ebook. This deck is really, really good. I stole a lot of stuff from it. So if you start reading it, you'll be like, oh, she stole it. And it's really good. It kind of tells you to focus for 2 hours, but you can go through it as you go, and there's videos and really clear explanations. If you're more interested in the creative part of machine learning, you have Creative AI, that kind of like a list of resources of projects mixing AI and machine learning, AI experiments as well. And this is the really good talks. They're very long. Each video is about 3 hours, but I kind of like speed it up, and it's really interesting to dig into the whole like philosophy and machine learning. I tried to put together some data sets, but honestly, try to Google, every time you want to solve a problem, just be like, open source data sets, blah, blah, blah. But I think getting started with the handwritten digits and trying to understand the algorithm is quite good. This is like a data set of faces of people in like different backgrounds. So if you want to do some type of facial recognition. And this site here has like a longer list, and I didn't want to copy it because, it's just there. I'm done. That was a lot. I'm sorry. If you have any questions, I tried to explain it as clearly as I can. It's still something that's a bit blurry to me, but hopefully some terms make a bit more sense now. Otherwise, I hope you're not scared to try it, because it's really cool. It's just very different from web dev. So that's it. Any question? If you have any question, feel free to, like the people who know as well, feel free to answer them, because
How is the accuracy of a machine learning algorithm calculated? Is that when you reserve part of your training set evaluations?
Yeah.
And then you write a bit of code that compares it with the answers? And
So that's why I don't think that unsupervised learning would have an accuracy, because you don't actually want to. I don't know. I haven't played that much with unsupervised, but I think supervised, it's taking the part of the training data that you only use for training, and then you have your evaluation part, and it kind of sees the accuracy is like, oh, did it figure that out properly based on the data that I gave it.
So once you train the model, and you have, for example, you have a model that finds bottles everywhere, and it's a model. So this software is like it's enclosed, so you cannot see how they find that, or like how do you play with this model? So suppose I can get just, for example, I have this model that finds bottles. Can I just get it very easy and put it in my phone, and when I point the camera, that's like a bottle, because this model's already been trained a million times.
So
how does it look like?
When you have, when you train your algorithm to kind of produce a model, I do think, and I'm not sure, that you can require that model anywhere and feed it a new image. I think that's why a lot of people are starting to look into ML in the cloud with the Google services and Amazon and stuff, because they allow you to do that whole training in the cloud, and you just do a request to a certain model. I think I really haven't played with that, but I try to think, I think it's that way, that you could point your camera at an object, and it would kind of, I think you would have the pre-trained model, and it would then understand what a beer is, but it wouldn't know what a chair is if it hasn't been trained on that. But I think you have data sets of various type of objects, so you could probably do that and that, but they're not always accurate. I've tried some of them where I pointed at a beer and it thinks it's a phone, so it kind of needs to be trained again and again. But I think once you create a model that's like in a file, you can then require it and use it for your actual live data, but don't take my words for like, yeah, I need to double check. But I think I know, like, that's how it works. Yeah.
So the real value is on the models. So once like Google train all the models, you can, for example, sell or like resell. I don't know. You can use the service to like use our models because they're all just very well trained.
Yeah, the thing is, what you would want is to be able to retrain the model, because maybe there's a new type of bottle or whatever. Like if you want to make it super accurate, it's about being able to retrain it. And I think that's also why having machine learning in the cloud is good, because you can retrain it easier than sometimes. Let's say you want to build a machine learning thing for work, and then you push the model, like you have your model in a database or something. You can't retrain it whenever you want. I'm not explaining that very well, but I remember having a conversation where the purpose would be to be able to retrain your model with new data and then serve the kind of like the new predictive model, rather than like you could have some issues with just having a model that you can't retrain because it's not in the cloud or something. So
I've seen the Google Cloud presentation about the new machine learning for the Google Cloud, and then they're doing example with the clouds. So you're feeding with I don't know 100 images of cloud, and then specifying which type of cloud it is, and then we output to you like which cloud it is, but they're using it as a service. And then they say, look, that's way more powerful than you use it supposed to do yourself, because we have like the team.
They can retrain it, and all you do is a request. So yeah, I think that's why playing, like if you wanted like to build something in production, you would probably look at machine learning in the cloud. If you want to play on your computer, you don't have to try that, but it's better in the cloud.
Yeah, I was just wondering, how does this go with something like hacking? Can you like train a computer to hack through, and then can you train another one to fight another one? Like, is it that advanced?
What do you mean by hacking?
Can you get it to learn how to like break into a system and like learn the ins and outs by, I don't know, giving it a dataset to get in?
I would need to know how to hack into a system to then train a machine, but it's, I think like a model is just as good as what you train it to do. It's a bit like, I think people were talking about how when you go to school, you're depending on the teacher that you'll have and what you're taught, you will go a certain way, you will know a certain things. So if you train a machine with instructions to do certain things, then it will be able to do these certain things. But if it's never done, if I don't know how to hack something and I think I can build an algorithm that can hack for me, I don't think that would work. Might be wrong, but
that's where unsupervised learning gets really helpful, because if you've got, like, if you don't know how to do something like Charlie was saying, you need to give a label. So you like you receive a piece of data and you say this is the result of it. With unsupervised learning, you can describe sort of patterns and say, like say with a hashing example, you say I want you to make requests to this service, and you have a process of like rewards or punishments. So you could say if you go there and you get a good error, like if you get an error message, then you did something wrong. And then make another request, and if you get a success message, then you did something right. So you sort of can train it, that's unsupervised learning, where you sort of like, just say keep doing something and figure out whether you were right as you continue on to it.
That's the thing, is that you will have to train it again and again and again, and you have to tell it yourself, yes you did right, no you did wrong, or you would have to have something, if you get a 404 then you did wrong and try again, and like you could probably, maybe you could get somewhere, I don't know, because I don't know how to hack into a system myself. I wish though, but yeah.
Sorry, I have a word. What form does your swipe data take? Like, was this like little video captures, or is it a?
So it's just text files of data. So it's just like it's kind of like a motion sensor, but a bit more advanced. So it just gives me back like a value as an integer, and I just save every time I record. I save that in a file, and then I give all these files to my training algorithm. And then when I do it again, it tries to find a pattern that matches either up or down. So it's just numbers, really, in text files.
Like for each kind of quality.
So what I do is that every time, so I kind of like launch the training session, and I do it like 20 times, and I record, and it creates like 20 files for each time. So in like I'm about like 3,000 times now. And yeah, that's why the more data you have, then I give all this data to the algorithm, and it's really just text numbers, like, yeah. So that's why I don't even know if I'm doing it well, but I'm trying. But I need to try on the other side this time, yeah. But yeah.
So is it storing numbers, or is it literally like generating a text file and populating that with
So it's a Python script, so you can, it's like an Arduino, so you can read it from the Arduino terminal, but I just wrote a Python script that takes the data, and when I release the button, because I train it by pushing and releasing the button, so when I push, it records, and I do my gesture, and then I release the button, and it takes that data and just create files. So it's a Python script that creates files and files and files. And then I have the, like everything is in Python, and then it just kind of like takes all my files in my data folder and just feed it to the algorithm and try to give a prediction. Same thing, like it's using support vector classifier, which is a type of supervised learning, but maybe it's not the right one, or maybe my parameters are not right, or maybe the way I'm getting the data from the Arduino is not right. So it's going to be quite a lot of work, but it's still interesting to kind of apply. Like, there's some people at work doing machine learning online courses on for AWS and stuff like that, and I find it very hard for me to focus on that kind of stuff because it's so abstract. So I'm trying to learn machine learning, but in a way that makes me excited. So either the art with pictures or hardware. It's pretty exciting, but it's a field that I'm not an expert at all, but I think it's really interesting. So yeah. Thank you very much. If you want the slides, let me know. I have them, they're here. So now you can go and get drunk. Yay!